Hey guys, this is Antonio Rivera doing the constant velocity, constant motion lab. Basically what I did was I observed a video of a tennis ball going towards a racket and tried to model it using Python software, tracker software, Newton's laws, and momentum principles. Here's the tracker video. I found basically the diameter of a tennis ball and use it. It's right here, and I used it to just relate the distances to real life and have accurate data. I placed the axes in such a way that the tennis ball is running across the x-axis, and right about here I start taking frames of the point of mass. All of that data is getting recorded, just analyzing the motion of the ball. It's being recorded right here, and I basically use that data to find some information from my Python code, like the initial velocity, change in position over change in time ended up being 0.51 meters per sec. Of these points I found from the data from the tracker vid. The mass of a tennis ball, 0.057 kilograms, I found online. Delta T, I assigned it a value of 0.01 secs. I think that's going to work nicely with a delta T of 2.12. And I found our initial position, negative 0.061 meters, to be that, and I found it from the tracker vid. My prediction, the initial force has to equal the final force for the constant velocity of the ball. For that to happen, F net has to equal 0. Let me show you the Python code. Okay, so that data I talked to you guys about, I inputted all of it into the system properties initial conditions part of my code. The ball's mass, initial position, initial velocity, and delta t can all be found right here. Here's where the code equations actually start. F net, I set it to 0 because of the reasons I already told you guys. And here's just some equations. I used Newton's equations and momentum principles to find those. Let me show you how this actually runs. You basically have the ball running in constant motion. Here's the data illustrated in a graph, and I actually extracted that information and graphed it alongside the results for the tracker vid, the actual data from the tracker vid, which is the realistic one. Here's the data from the tracker vid, here's the data from my model. They're basically the same, just a change in x, probably because I didn't actually put the time, just probably because of glitches in putting the time right, just because I'm new to using these programs. But I think the data was modeled excellently by my model, and yeah, that's basically it. I have a what if question. What if I changed the origin of my tracker vid software? If I change this origin, it'd still be more or less the same data, it'd just be a change in proportions. This line right here would still be the same, it'd just be in a different part of the coordinate plane, but it'd still be the same equation, more or less the same equation. So yeah, it still illustrates the same motion, and basically, yeah, the data was excellently modeled, and as far as push and pull that we can see in this video, there's just an initial push right here when the ball is being thrown towards the tennis racket, and it maintains that initial force that it got all the way up here. And thank you guys, this is Antonio Rivera, have a good day.